Hey everybody, in this video we're going to talk about conditional probability. And what is conditional probability? That is when the outcome of one event in some situation is dependent on another event happening first. Okay, so that means just what it says, that you have to have one thing happen and then you look at the probability considering that first thing already happened. And this is written as the probability of A line B. And what this means is that the probability of A, which is this first bit, given that, which is this second bit, right? We call this line here given that, the probability of B has already happened. Okay? So, and that of course is this last bit. So the probability of A given that B has already happened. All right, so that's generally what we're looking at, and this is how it's written. Probability of A line B. So we say probability of A given that B has happened. And how we can find that mathematically is we can take the intersection of A and B and we can divide it by B. Now, how do we get there? That's kind of the big key for this. So let's look at an example. Let's assume here, I'm just going to pop an example on here. Let's say that we surveyed 100 people and we asked if women in the armed forces should be permitted to participate in combat. You know, this is sometimes a controversial issue, so it's a thing that people would want to know. So let's say we have our set of data, and we've got people who say yes and no, and we've got males and females answering here. And I'm just going to populate the data with this, or populate the table with this data. Now, before we can begin, it's a good idea to get some generalizations, some summaries about this table. So we can find the total of each row, and let's see, 32 plus 18, that's 50, 8 and 42, that's 50, so there's our 100 people. And if we look at our columns, that should also add up to 100. So we got 32 plus 8 is 40, 18 and 42, that's 60, so we've got our totals. And I put these kind of dotted lines up there. You don't have to put up the dotted lines. You can put it however you want. But basically this is saying that we've got we've got a set of data within the table, and then we've kind of summarized the bits on the outside. And this type of table is called a two-way table. And it's called a two-way table because we've got the data represented in two different ways. We've got it represented as yes and no values, and then we also have it represented as male and female values or results, and then we break them into individual pieces within there. So having those two results displayed is why we call this thing a two-way table. And for our probability purposes, let's say that M is that the respondent was a male, that F is the respondent was a female, right? And that we have Y equaling the respondent answered yes, that the women should be able to participate in combat, and N equals the respondent said or answered no to women should not be permitted to participate in combat. So we're going to find this probability of this idea of probability of A given that B happened using the table, and then we're going to use the formula on the left as well. So let's start with the probability that the respondent responded yes, given that the respondent was a female. Okay, so what happens is first we look at the female piece, and then we look at the yes piece. Okay, so first we want to consider ourselves with just our females. So we're looking at this whole column of females only. So that means we're excluding all the males, so we've basically narrowed it down to half the population. And then we're looking at the people who said yes. So that's 8 women out of the total 50 women responded this way, yes, given that they were a female. And we can simplify that to 4 over 25. All right, so that's how we get that. The 8 out of 50, 8 women out of 8 women responded yes out of the 50 women who responded. Now, if we look at it using the formula, we've got the probability of yes given that they were a female. And what we're going to do is we're going to find the intersection of these two things. So we're going to find 8 over 100. Now that's 8 people out of 100. So A and B is yes and female out of the whole group. So that's how we get the 8 out of the 100. And then we're going to look at the probability of just B. So the probability of just a female. So that's going to be 50 out of 100. And when we start calculating this, we get 8 out of 100 times 100 over 50. Right? When you're dividing fractions, you multiply by the reciprocal. We start simplifying, and you can see where this is going. That we got 8 out of 50, or 4 out of 25. So let's look at another example, and this time we'll start with the formula, and then we'll see how it works with the table. So we'll kind of go both ways here. So here we've got the probability that a male answered, given that they had said no. Okay, so to begin with, we're going to look at the intersection of these two things, where it's male and saying no. So that's going to be 18 out of our total 100. So 18 out of 100, right? So that will be in our numerator. And then we want to look at the probability of them just saying no. So the probability of saying no is going to be 60 out of 100. Okay, so now when we simplify, we should get 18 out of 100 times 100 over 60. Simplify, we get 18 out of 60. Let's see, these are both divisible by 6, so we get 3 out of 10. Okay, so now let's look at it using the table. So we're going to say the probability of male given that they said no first. All right, so we're going to look at the no first, and then we're going to look at the male. So first thing we're going to do is we're going to narrow it down to this entire column, the no column. So we're looking at just these 60 people who said no. And then we're going to look at the men who said no, and that's the 18. So we've got 18 over 60, which simplifies to 3 over 10. So that's where this formula for the P of A given that B happened comes from. So hopefully this makes sense when you look at it with data as well on how we came up with this formula. So whether you're given a whole table or whether you're just given some numbers, you can plug in and find these values of conditional probability. So I hope that helps, and I will talk to you in the next video.